Good evening, student. Today I am discussed about the operational amplifier. The short form name is op-amp. It was discovered by Robert Whitler in 1864. The operational amplifier, the name suggests that it performs various operations like integration, differentiation, inverting, non-inverting, as well as some amplification purpose we will use signal amplification, as well as it can be used as a analog to digital converter as well as digital to analog converter. This is the IC chip of IC op-amp chip of IC 741, and this is a 8-pin IC integrated circuit chip. Here it is one notch is there, and at the left hand side it will start from 1, then 2, 3, 4. 2 and 3 are the input. This is the inverting input terminal and this is the non-inverting input terminal, and this is the VCC minus VC 4 pin, and 7 pin is plus VCC, and 6 is the output. These two are also input, and it regulates the op-amp output at a certain voltage. This is the offset null, and this also the offset null. This is the circuit representation, IC representation of an op-amp, and this is the symbolic representation of op-amp. Like these are input, inverting and non-inverting, that I discussed here also, inverting and non-inverting. This is the plus VC minus VC. These are all our ideal characteristics of op-amp. What are the ideal characteristics? That is infinite voltage gain, infinite input impedance, zero output impedance, infinite bandwidth. And these are all ideal characteristics, and practical op-amp, whatever we used in laboratory, these the characteristics is some little bit different from that of the ideal characteristics. It means if the ideal characteristics of the op-amp is the infinite voltage, then it can be high voltage gain for practical op-amp. Infinite input impedance, if it is ideal characteristics, then it suggests that the input impedance is very high, output impedance is very low in case of a practical op-amp, whatever we used, that is 741C. Here this is the inverting amplifier, because I told in the previously that op-amp also perform as an inverting amplifier. Here it is Vi voltage is applied at the input terminal, and this is the virtual ground, and this is connected through the resistance R, and is the feedback resistance, and this is called feedback because this is the common path between the input and the output terminal. That's why here the voltage virtual ground. Why it is called virtual ground? Because as the infinite input impedance, characteristics of op-amp is the input impedance is very high, so large amount of current will flow through the feedback resistance. That's why no amount of current can flow through the op-amp. But in case of a ground terminal, when we consider as a ground, so whatever happen, ground can serve as the source of the infinite current, but here it is not a source of the infinite current. That's why it is called the virtual ground. That's why if I consider here, I also consider the voltage is V. So that's why it is Vi minus V according to the Kirchhoff's law by R is equal to V minus V0. It is V minus V0 because current is flowing through this terminal, V minus V0. But here V is 0. That's why it is reduced to 0. So that's why Vi by R equal to minus V0 by RF. V0 by Vi, V0 equal to minus RF by R into Vi. So voltage gain happen is minus RF by R. If we consider the RF equal to R, then V0 minus V0 by Vi equal to what? Minus 1. And V0 becomes Vi. So what we can get from this equation, that is output is inverse to the input. Whatever the input is given in case of inverting amplifier, it gives the reverse output. Means if we give the 5 volt output, we will get the minus 5 volt. That's why we can say that the phase difference between the input and the output terminal is 180 degree. So one should arise question, why we consider this terminal and this terminal at the same potential. So here you will get the answer of this question. This is on the circuit diagram of op amp. Here I consider the input is connected with the plus terminal, means inverting, non-inverting terminal is connected with the voltage Vi, and another terminal is grounded. But symbolic representation inside this op amp, there is some large resistance is there, one large resistance, that is R. In this way it is connected between these two terminals, and this is that's why here it is the resistance is very high, so current will be very low according to the Ohm's law. We also know that if the resistance is very high, the current is very low. So if I apply the law of Kirchhoff's law, that is voltage rule, that is Vi minus Va by R1. This is, I consider here it is R1. Mistakenly here written as R, but here I will consider as a R1. So Vi minus Va by R1 equal to I. As we know, it is the very high resistance, so I is normally equal to 0. So Vi minus Va by R1 equal to 0. So Vi minus Va equal to 0, and this is reduced to Vi equal to Va. That's why we will here consider, if I apply 0 volt here, it is also applied here also. Why? This is the answer of this question. So question may arise, why we choose these two terminals at the same potential. The answer should be written in this way. So today I will discuss about up to this. Next day I will discuss about the non-inverting input amplifier. Thank you.